Okay, now we will see GPIO in Open-Drain configuration. Previously we have seen that GPIO in output mode. Okay, we understand this block diagram. You can see, we know how that flow is there when we give 0 or 1. On the basis of that, the P MOSFET or N MOSFET get activated and it will pull the LED to VCC, or it will pull down the LED to the ground. Okay, so what is different in this GPIO Open-Drain configuration? The word itself says that Open-Drain, in which in same diagram we will see that in Open-Drain configuration this P MOSFET is not available here, only N MOSFET is there. Okay, I will draw another diagram for it. Okay, I am here drawing N MOSFET. Here it's in drain and source is a gate. Okay, directly connected to pin, and that source directly connected to ground. So in this diagram you can see that when this NMOS transistor is switched on by giving, here I am giving input whatever it is, 0 or 1. When this NMOS get switch on, the pin is pulled to ground, okay, or you can say low, and when this transistor is off, the drain of the transistor is floating or open. Here I am writing word floating, open. Okay, so we can see that here that open drain configuration can only pull down the pin and lack, or not able to pulling up the pin. Okay, so it lacks the pulling up capability. So we can say that it has only two states. First is ground and second it is float or open. The float is useless, means we cannot use this. We can make this float as useful by providing the pull-up capability, by adding pull-up resistor and all. I'm going to explain that also. I'm just saying, without pull-up, this floating pin is not useful for us. So now I am updating this diagram with pull-up resistor. Okay, again same and MOSFET I'm drawing. Then here pin, here gate terminal, here not gate, an input. Okay, this is connected to ground, drain, source, gate. There are two type of pull-up resistor. When I connect pull-up resistor before pin or inside microcontroller or anything, inside pull-up is available inside, then we call it as internal pull-up resistor. Nowadays that microcontroller we are using, they are come with this feature, that inbuilt internal pull-up resistor. We have to just enable it. Okay, if I connect resistor after pin or external, it called as external pull-up. So I am considering only internal pull-up now. Okay, removing it. Okay, to understand this. I'm connecting an LED here. LED connect to ground. Here also you can connect limiting resistor. Current limiting resistor you can connect. Okay, now we'll see how this works. Okay, when we give 1 to its input or write 1 to input, how we see how this flows. Then this NOT gate will give me 0, so 0, this is an NMOS. So at 0 applied across the NMOS gate terminal, we can say the NMOS is switch or turned off. Okay, this NMOS will get turned off. So the LED get driven by this VCC through internal pull-up resistor. Okay, we can see here I am getting VCC. This is turn off, so this and ground here. Okay, when we give 0 as input, or we write 0 as input, here I am giving 0, so after NOT gate I will get 1, as 1 is applied across NMOS gate terminal. Then this MOSFET get NMOS gets turned on, so it get turned on. As it get turned on, the LED pulls down to ground here. Okay, and LED off. Here I forgot to write LED on. Okay, this is how the open-drain configuration works. Okay, it's easier. Mostly used in many applications are there. Mostly used in I2C communication protocol. We required this in I2C communication protocol.